Hi everyone, and welcome to our video on solving a right triangle application involving the angle of elevation. So in all of these word problems, make sure to draw a picture, and then it's either doing SOHCAHTOA and or Pythagorean's theorem. So any right triangle, you always have these two to help. All right, and then here's just making sure we know some of the vocabulary. So an angle of elevation is measured from a horizontal, and let's say this is like a person and he or she or they are looking up at something in the sky. That's the angle of elevation. Okay, so that's the angle of elevation, and the same thing, it could be over here that they're looking at. Maybe they're looking at something right here, so like a balloon. This right here would be the angle of elevation. Okay, so those are two different cases, so it just depends on where it is. Okay, so now I just drew a little arrow. These are called the line of sights. Line of sight. Okay, so angle of elevation always measured from a horizontal. Okay, so the closest distance from a horizontal, or the smallest angle from a horizontal. So every time, something like that. So both of those are angles of elevation. And the angle of depression, let's do that in blue. Angle of depression, so depression, like you say you're down, you're looking down then. So this time we're high up already. So here's our horizontal. And then this time I'm looking down at something. So maybe something like right there. Again, it's measured from the horizontal. So this is the angle of depression. Or if I'm looking down at something way over there, from the horizontal like that would be the angle of depression. So those are two examples of angles of depression. And then this last one, the angle of inclination, often they usually just draw the picture. The picture is given. So, because they're tough to understand, or it's just straight up an angle of elevation. Okay, so they're kind of the same. So an angle of inclination means you're on an incline already, and then you're looking up at something like that. Okay, so that's why they usually draw a picture already. So that one we often don't have to translate. All right, anyway, so in this problem, we have a person is 30 feet from the base of a building. If she measures the angle of elevation to the top of the building as 60 degrees, what is the height of the building? All right, so we'll just break this down. So these word problems, often there isn't too much going on. So I'm just going to say, well, here's my person. It says a person is 30 feet from the base of a building. Okay, so this is 30 feet. And then here's our building. Okay, so we don't need to draw an actual building. I'm just going to say there it is, just a vertical line. So 30 feet from the base. So the base is at the bottom, base of the building. If she measures the angle of elevation to the top of the building, so if our person's here where I'm doing it extra bold right now, that is our horizontal. Okay, and we could even extend that if we need to see the full horizontal. There's our horizontal. We'll abbreviate it. And then they're looking at the top of the building. That means this is the line of sight. So our measurement is right there. So they're saying there's the 60 degrees. So if she measures the angle of elevation to the top of the building as 60 degrees, there it is marked. I'm assuming the building is straight up and down, so we know that that's a right triangle. Now it's asking what is the height of the building. Okay, so the height, I'm going to mark that as X right there. That would be the height of the building. Okay, so now that we have a right triangle, I can either do SOHCAHTOA or Pythagorean's theorem. Well, Pythagorean's theorem doesn't look like it's useful because I only have one side, so that means it's a SOHCAHTOA problem. So if I have an angle, I can use SOHCAHTOA. Okay, and then based on the angle 30 degrees, or not 30, 60 degrees, so I could find the missing. The missing was 30, but I'm not even going to mark it. I'm going to just say, well, based on this 60, I know directly opposite is X. The longest side, which I don't need, is the hypotenuse. The 30 is the adjacent. Okay, so I need to find opposite and I have adjacent. opposite and adjacent is the tangent. So that's the one I want to use. So I have tangent of 60 degrees is equal to opposite x over adjacent 30. Okay, so I know the tangent, and we can still always write that out. Tangent of an angle is opposite over adjacent. I just went ahead and plugged in the angle was 60, opposite was x, and then adjacent was 30. Okay, and I want to get x by itself, so we would multiply both sides by 30. And that would give us x by itself, so we have 30 times tangent of 60 degrees is x. Okay, however, if you see an angle that you can do without a calculator, they usually like you to do it. So tangent of 60 is something we can do. Okay, so there's where 60 degrees puts us on the unit circle. Remember, tangent of theta is your y coordinate divided by your x coordinate. So this would be, so tangent of 60 is that square root of 3 over 2 divided by 1 over 2. Those 2's would cancel. We're left with radical 3 over 1. I don't really need to show the 1. So that means this tangent of 60 is the same thing as the square root of 3. So it's 30 times the square root of 3 feet is the height of the building. Okay, so that's our exact value answer. If it wants a decimal, let's go ahead and get that. So I'm going to just plug that into the side real quick. I don't think you can see it on my screen. Oops. Okay, so if you can, nice. I just wanted to get that the decimal approximation anyway. It is 51.96. Okay, so in case it wanted it, so I just wanted to plug that in real quick. Okay, so that's it. So usually we, again, with like stuff in class and what's most important is things without a calculator. Okay, but sometimes in the homework they want it. Okay, so that's it. So often word problems are a lot nicer than other problems because there isn't, you don't have to find everything. You just find the one little thing that they want, and often it's pretty quick. Okay, some can be nasty. Word problems can be nasty, yes. But that's it for this one. Okay, so thanks for watching. If you have questions, please let me know.